is I want to start by drawing our grid. And what I want to do is put theta at the origin like we have in the past and create theta to be 30 degrees. Okay? If theta is going to be 30 degrees, I have a 30, 60, 90 triangle. Now, when you had a 30, 60, 90 triangle, what was opposite the 30?
Root 3.
1.
Okay.
Opposite the 60 was square root of 3. And opposite the 90 was 2. So this point here, what would the ordered pair be for that point? Which one?
Root 3, 1.
Root 3 and 1. My ordered pair here is root 3 and 1. My x value is root 3, my y value is 1. Everybody okay with that?
Yeah.
All right. Now, what I want to do here is kind of show you guys where reference angles come into play. Well, in order to do that, we're going to flip this into the next axis. Or quadrant, excuse me. Am I still a 30-degree angle?
Yes.
So I'm still a 30-degree angle for theta. Opposite my 30 is what?
1.
Opposite my 60 is square root of 3. But now what happens? It's negative because it's on the left side. Everybody with me on that? What does my ordered pair become here? Okay? Take the same one. Shh, gentlemen. Oops. I flip it around. I still have a 30-degree angle for theta. It's still placed at the origin. Opposite my 30 is how much now? It's still a value of 1, but now that it's moving downward, it is a negative 1. So this ordered pair now becomes what?
Negative root 3,
Negative root 3
negative 1.
and negative 1. And then lastly, we clone it and we flip it back into the other one. When I come back over there, when I go back to the fourth quadrant, notice my value of x, again, is root 3. My value of y is now negative 1. The one thing I want you guys to see here is that did theta change in any of those quadrants?
No.
No. Theta didn't change at all. Theta was the same value each time. But as you go through this angle is 30. This angle is how much?
150.
150. This angle is how much?
Yeah. What?
210. Bless you. And this angle is
280.
330. What we've shown here is that 30 degrees in quadrant 2, quadrant 3, and quadrant 4 is the reference angle for 150, 210, and 330. What basically this is allowing us to do is it's showing that it is 30 degrees off 180. This is 30 degrees off 180. This is 30 degrees off of 360. That is a reference angle. The reference angle is nothing more than how far is it bounced off of the x-axis. All right? What happens here again, guys, these reference angles are nothing more than how far are you from an axis.
Is that why we did coterminal?
Yeah, that's exactly why we talk about coterminal. That's exactly why. Because you can draw it and find out its reference angle by how far is it bounced off of the x-axis. We're always going to be talking about reference angles in terms of being positive. Okay? Reference angles will always be positive. Even if your original angle was negative, your reference angle is still going to be positive. And we'll show many examples here as we go through this. So think about what we just looked at here. If I was in quadrant 1, or excuse me, quadrant 2, let's start this fresh. We were in quadrant 2, and we had that 150-degree angle here. How far off of that is for the axis? It's 30 degrees. Does everybody agree that this is 180 degrees here?
Yes.
So, if your theta is in quadrant 2, your reference angle, bless you, equals 180 minus theta. If your angle is in quadrant 2, your reference angles can be 180 degrees minus theta. Theta will be your given angle. I gave you guys theta at 150. Okay? If I say that theta is 100, what's your reference angle? 80. If this is in radians, if I'm in radians in the second quadrant, let's say 2 pi over 3. If I have 2 pi over 3 instead of it being at 180 degrees on the axis, what does that become? You're in radians. Pi. This is pi. So how far away is 2 pi over 3 from 1 pi?
1/3.
A third pi, yeah. The reference angle here in radians, the reference angle is going to equal pi minus theta. When you're dealing with fractions, remember we did this with coterminals. Remember how we switch everything to have that common denominator? Just do that. So if I have 2/3 pi, I know it's in the second quadrant because it's more than a half, but not a full. I would set it up as 3 pi over 3 and subtract out 2 pi over 3, and I get pi over 3 as that reference angle. What that means, well, it's going to become real apparent here as we get into our unit circle. We're trying to mirror what the special right triangles are in the first quadrant. If we know our values for the first quadrant for the special right triangles, we know everything. Because everything else is just mirrored off of that via reference angles and the different signs. And when I mean signs here, I mean the positives and negatives, SIG. Okay. Is that okay for quadrant 2? All right, let's look at quadrant 3. When I'm in quadrant 3, let's say theta is 200. It's in quadrant 3. If it's 200 degrees, how far off of 180 is it?
20.
It's 20. What did you do?
Added
Theta minus 20.
Yeah, that's exactly right. If I'm in degrees, to get the reference angle in degrees, you take your theta, subtract 180. How far off are you from the x-axis? If your theta is 200 degrees, it's 20 degrees past 180. Your reference angle is 20. From those values, you're going to be able to bounce yourself back to the first quadrant by using those values, all those different ordered pairs. Obviously, we don't work with 20 degree angles very often. Well, probably when we start doing this stuff without calculator, you'll be working with the specials, 30, 60, 90s, 45, 45 degrees. Okay. Which basically means you're working with 30, 60, and 45. And you're going to be finding all those reference angles with that. Okay. All the coterminals. If this was in radians, let's say Q3 in radians, let's say that your theta is 8 pi over 7. If theta is 8 pi over 7, does everybody agree that's more than 1 pi? but not more than 1.5 pi. So if I draw that out, if that's 8 pi over 7, how much past pi is that? Yeah, pi over 7. Everybody okay with that? Again, you're doing the same idea. You take theta and subtract pi to equal your reference angle. In this example, it was the denominator was 7, so we took 8 pi over 7, subtracted 7 pi over 7, and we got pi over 7. How far have we bounced off the x-axis? That's all you're looking for when you're dealing with reference angles. How far off of them are you? And then obviously the last quadrant. If I'm in quadrant 4, let's say theta is 320 degrees.
360 minus theta.
Yeah. Again, if I'm at 320 degrees, it pushes me into the fourth quadrant. How much further do I have to get to be at 360? My reference angle here to bounce back up. So in degrees, your reference angle in degree is going to be 360 minus theta. For radians? Quadrant 3 for radians was theta minus pi. And if this was in radians, yeah, it's 2 pi minus theta. Very good. Okay. Yes, sir.
So do you just not have to worry about this if it's the first quadrant?
No, because in the first quadrant, it is its own reference angle.
All right.
And that's been asked in all the other classes too. Whenever you're in the first quadrant, how far are you off of the x-axis? Whatever you are. You are your own reference angle in quadrant 1. You got that going for you. Okay. Not so bad? Yep, we're only worried about x-axis. Because again, what this is going to allow us to do is once we know a set ordered pair over here, a cosine and a sine, this is the same reference angle over here. It's the same reference angle over here. It's the same reference angle over here. Which means these 4 points are the same, except positives and negatives. That's the whole idea. That was very good.
That was French. You're
Is
French.
it possible to just angles over 360 degrees?
Absolutely. You get its reference angle, not reference angle, coterminal. When you have one that's more than 360 degrees or more than 2 pi, you find its reference angle, and then you build off of that. And I've got examples of that coming in. That was the whole idea of learning how to do coterminals as well. Okay? There was methods. All right? There was methods behind my madness. Well, I'm going to do some right now, so it's no biggie. Let's see here.
I get it. The brain's not there.
All right, let's look at this. I want to find the reference angle. I'm going to draw the angle and find its reference. Now, if I'm 7 pi over 4, 4 goes into 7 how many times? How many are left over? Okay. So when I go to draw this out, I know that this is 1 pi, 1.5 pi, 1 3/4 pi. Everybody okay with that?
Yes.
What quadrant am I in? 4. So that means in order to figure out what my reference angle is, it's going to be 2 pi minus 7 pi over 4, which means I'm going to write it as 8 pi over 4, just to get the common denominator. What's your reference angle? Yep, my reference angle here is pi over 4. Which means it'll have all the same characteristics of the pi over 4 in quadrant 1, except what sign, S-I-G-N, is changed. Negative y. And negative y is dealing with the negative which value? Right. The sign of sine changes.
Ah.
Okay? I'm really not funny. Yes, I did. Thank you for catching that. That was the idea. And here's what you're asking about, Morgan. 390 degrees.
So you just sit there, 360. And then it's a 30-degree angle, so it's already its own reference.
When I'm at 390 degrees, I'm more than one revolution, which means you got to find the coterminal of it. So if I graph this, here's 360 and there's 30 more. Oh, I just said it, right? What is the original angle then? 30. So the reference angle here, since I'm in quadrant 1, will be 30 degrees. Okay. Nope.
So all we have to do for this section is just find the.
What we're doing is we're finding a reference angle right now. This is a huge thing to be able to do. This is very, very important. Okay? This is very important.
This is the home run, just never find the reference angle.
No, it's something different.
Really? Well, like, is it like all the problems find the reference angle?
Pretty much. I got another part to it too, but we'll get to that in a second.
Negative, so just 120.
If I'm at negative 120 when I go to draw my angle, that means I have to go the other direction. Everybody knows that, right? So I'll be
We've
in.
done this before?
Yeah, we've drawn negative angles.
I don't
Well,
remember.
we haven't actually.
I don't think I've ever done
They
that.
basically just go the other way.
All it is go the other direction. So my negative 120 degree angle puts me in which quadrant? Okay. How far off is that from 180 degrees?
60.
So what's the reference angle? Reference angles are always positive.
So, does it make a difference if it's negative or positive?
Nope. Because you can still find the reference angle, and I heard you guys saying that earlier. The positive coterminal, like you guys said, it was 240. 240 minus 180 is 60. Okay? You can go that route if you like. It works out just the same. What do you guys think?
They're swearing, I hear you.
Ready? Oh, yeah. Yeah.
What?
Negative 2 pi over 3. If my radians are negative 2 pi over 3, again, I'm going the other direction. That's more than half, but not yet a whole. Everybody agree?
Yeah.
So I'm coming around. There's my negative 2 pi over 3. How much is left to get me to a pi? Pi over 3, and that's it. Your reference angle is pi over 3. If you look at it upside down, could you just say that it's 2 pi over 3 and then you just move it around the other way?
Yeah.
It's kind of what you're doing. Instead of finding that, I mean, if you want to find the positive coterminal and then subtract it out, it works the exact same. It'll work just the same. But if you flip it around, when you're dealing with it in radians, it works out real nice that way too. What's that? When you flip it upside down?
Yeah.
I didn't mean to crush your soul. I'm sorry.
Murph, when do you think Teddy Bridgewater is going to be drafted?
I have no idea what you're talking about, nor do I care. I don't really have anyone this either.
All right, you just hurt my feelings.
I'll get over it.
Murph, next time we're drawing you on the board, all right?
We're gonna permanently The other part of what I want you guys to work on tonight
Permanent marker.
is I want you guys to create this table. What is the pattern for your sides when you're 45, 45, 90? Okay, so it's x, x, and x root 2. Can I rewrite that as 1, 1, and root 2?
Yes.
Okay? If I do the same idea for 30, 60, 90, what does it become?
1, 2,
Root 3. Oh, I thought you said 2. 1, root 3, and 2.
I go to root 2.
Oh, I did. You didn't see it. It's gone. What I'd like you guys to do is I want you to create a table, a trig table for the 6 trig functions for the special right triangles. What I want you to do is I want you to write out your 30, your 60, and your 45 for the sine, cosine, tangent, cosecant, secant, and your cotangent.
That's our homework.
I want you to write part of it. I want you to make that table. All right. For all 3 of them. I want you to make the special, I want you to make the trig table for your special angles. Your 30, your 60, and your 45. Again, the reason that I'm doing this is because everything that we do on the unit circle is going to be based upon those values. Those values will never, ever, ever change. Once we understand how we find reference angles, when we do this stuff by hand, we're going to be able to do the following. We're going to be able to find, oops, wrong button, the cosine of 315 without the use of a calculator. What quadrant does 315 land in?
4.
What is the reference angle for 315? 45. The reference angle is 45 degrees. Now, that means it's going to share all the same ordered pairs for a 45-degree angle in the first quadrant, except what sign, S-I-G-N, changes. Which one? The X or the Y? The Y, very good. The Y value, the sign becomes negative. So once we understand what the value of the sine or cosine and sine of 45 degrees is, it's the same value here with sign changes, positives and negatives. Same thing here, that reference angle over here for 45 degrees. The 225 will have the same cosine and sine values a 45-degree angle does in the first quadrant with different positives and negatives. This is the stuff that we're pushing towards because I'm taking the calculators away from when we do these things on the test. You gotta be able to create this. And it all is based off of, really, to be honest with you, if you know these right here, those 6, everything else falls into place. Reciprocals are easy. Yes, sir.
So, on the test, will all of our questions that we don't get a calculator for be 30, 60, 45?
Yeah, but it'll be some variant of a coterminal angle. You know, like 315, it could be 225, negative 225. It could be one of those things. Well, you have to find out what the reference angle is. That reference angle without a calculator has to be a 30, 60, or 45. You don't know how to do it otherwise. I'm not going to make you do it.
I don't know how to do like a 22-degree.
Yeah, you wouldn't have to, okay? We're not going to worry about those types of thetas. Those types of thetas you'll have calculators for, and we will have that calculator, non-calculator portion here, okay? Questions about what I'm expecting you guys to do tonight?
Wait, this is our homework?
I want you to fill in this table that I have 8 other reference angles for you to do. On page 788, I believe it is 37, 45, oops, sorry. 788, 37 to 44.
40. Every other even.
Those values, those 8 are finding reference angles. Please draw the diagram, and then that way you can figure out what quadrant it is in easier, and then find the reference angles of those 8s. those 8 problems, you might not get one of the special angles as far as the reference angle. You might not get a 30, 45, or a 60. You might get, 10. But at least you're just getting the idea of the practice of setting those references up. Okay? Questions? You got some time.